Hello everyone, welcome back to my apparently ongoing series of school assignment videos. First was psychology, then we had health science, and then English. Now we have math, with also a new format for the video. Because, you know, what's more mathy than a paper in hands? Anywho, so as you can see from the equation we're going to be doing today, this is going to be a video on the trigonometric identities. So for this equation that we are doing, we are going to be doing the reciprocal and Pythagorean identities, which, in all honesty, is just going to be the reciprocal, but Pythagorean, just in case, keep those in mind. Now, if you're watching this video, I would assume you already know what the trigonometric identities are. However, if this is a video that someone has recommended to you for learning purposes, this will be semi-educational, I hope. Now, tan theta is typically an angle, along with sine and cos. But along with those three, there are three others, which is cosecant, secant, and cot. Which, if you do not know, cosecant is the inverse of sine, or reciprocal of sine, that's the word. Secant is the reciprocal of cos, and then cot, which is cotangent, is the reciprocal of tan. And then tan is sine over cos, and cot, if you don't want to do the 1 over tan, is just the reverse of tan, which is cos over sine. Now, thanks to this handy-dandy little cheat sheet my teacher gave me, this should essentially sum up everything you're going to need to know for this equation and many others. First things first, when you're doing a trigonometric identity question, is to look and see what you want to turn into the simplest terms, which in this case would be sine and cos. Now, I suppose I should explain what we're doing here. For this equation of sorts, we are going to be turning this statement into this one. Now, there's an equal sign here. However, as has been lectured to me by my own teacher, these two have not yet been proven equal. So, this equal sign is technically not correct as of right now, but we will leave it for the time being for show's sake. First thing we're going to want to do is find what we want to change. Now, personally, the tan squared looks a bit intimidating, so we're going to go for the tan theta secant theta, as these two are multiplied together, because these are more complicated than tan squared. Now, we'll get to that in a moment. What you're going to want to do with tan theta and secant theta is, first of all, look and see what they can be turned into. Tan theta can turn into sine over cos, and secant theta can turn to 1 over cos, which then, if we multiply those together, would then give us sine over cos squared. And if you look over here, we want a cos squared on the bottom, so that's a good thing. So now, what we're gonna do is just copy the rest of the equation. And now for tan theta secant theta, we're gonna go plus sine theta over cos theta, and then the secant, which this is multiplied, so you want to have that, or just put it all under one fraction if you, or not one fraction, all under one numerator if you feel confident in your ability. However, as this is a step-by-step process, I want to take you through it step by step. Now, for secant theta, that is 1 over cos theta. And now, with these together, we will get sine theta over cos squared theta. And there we go. Now we are a little bit closer to our end result. Now, as we have it where we have it now, we will then look at the Pythagorean identities, because I forgot that we do actually have one for this. So, as you can see right now, we have a tan squared plus 1. The Pythagorean identities are all about the squareds. So, for example, we have sine squared theta plus cos squared theta gives us 1. But we have another one, which is 1 plus tan squared equals secant theta. And what do we have here? Tan squared plus 1. So, for this particular equation, it is definitely easier to just get all your terms together. So now we turn this into a secant squared theta plus sine theta over cos theta. It's getting a bit jumbled, but that is a theta, I promise. Now, secant theta, as we know from up here, turns into 1 over cos. And because it is squared, that squared will go onto the cos. Now, also with it being addition, that cos will stick to just cos squared, therefore getting us our end result. Which then, 1 plus sine, all over cos squared theta. Because with addition and fractions, the denominator does not change when they are the same. So, you have yourself a satisfying QED. So, there are the simplest of steps that you can take to then do your own equation, depending on whether it be the reverse of this, 1 plus sine over cos squared. You can then find a way to turn it into tan squared theta plus 1 plus tan theta secant theta. You can do the inverse, you can do the reverse, you can do any other question with these simple steps, along with the rules that I probably should have mentioned. However, all you really need to know is basic multiplication, addition, subtraction of fractions, along with that you want to get these into the simplest terms that you can, no matter what you're doing. And also, be careful of the squareds. You forget that, your entire thing is thrown off. I speak from personal experience, it is not fun. Now, I thank you for your time, and I hope this helped you as much as... well, I'm no Mr. Parker, but I hope this helped somebody. Anywho, thank you for tuning in, and I will see you all next time. Bye-bye!